Welcome to the AI Chat Podcast. I'm your host, Jaden Schaefer. Every day we break down breaking AI news stories and explain their implications in your life and in business. If you are interested in seeing really interesting AI use cases, make sure to follow me over on x.com, formerly Twitter, as I will be sharing some really cool use cases of AI, and I kind of, retweet some of the greatest things I'm seeing in the space every day. So make sure to follow me at Jaden_AI. I'll drop a link to that, but also my handle is in the podcast cover. I would love to have you in the community. Have you ever wanted to start your own podcast? I record and publish podcasts on a platform called Spotify for Podcasters, and I absolutely love it. Essentially, you can upload from your phone or computer, and it distributes to every platform that plays podcasts. They support video podcasts, and you can make money on the platform with ads or even podcast subscriptions, something that has made my life so much easier as a podcaster. So if you're interested, I highly recommend you give it a try. You can download the Spotify for Podcast app or go to spotify.com/podcasters to get started on your podcast today. Today, we have some breaking news out of Google's DeepMind on AI mixed with robotics. So let's jump in. Essentially, Google's DeepMind team is really pushing the boundaries of AI and robotics, and they're bringing a new, vision language action model. So this is the Robotics Transformer 2, which is the RT-2. And this cutting-edge AI model was trained on a massive amount of text and images collected from the internet. And this enables it to generate robotic actions, which is a massive step forward from traditional AI-based chatbots like ChatGPT or Google Bard, which essentially just generate text snippets for you, right? So this is really bridging the gap between web knowledge and robotics control. So robots, unlike chatbots, need a very firm grounding in the real world to, truly be able to be helpful to humans. And I think this has always been a very large task that they have to, comprehend and carry out really complex tasks in a lot of very diverse and often very unpredictable environments. To date, we have a lot of factories that have robots that are operating, doing very simple tasks. But as soon as you want them to be able to not just perform a repetitive task over and over again, but kind of do new things and learn and adapt, it becomes a much more challenging task to undertake. And because of this, I think the training of models like RT-2 represent a much more intricate undertaking compared to, training just a large language model or an LLM. So I think it's not just about, a robot recognizing an apple, for example. It has to understand the context. It has to differentiate it from a red ball. And it has to be able to perform various tasks related to that object. So I think historically, practical robot training demanded billions of data points about, the physical world. But RT-2 has ushered in a more streamlined approach. So building on RT-1's ability to essentially just generalize information across systems, RT-2 can actually create a single model capable of complex reasoning with just a fraction of the amount of, robot training data that is typically required. So let's talk a little bit about RT-2's kind of novel abilities. So what makes RT-2 unique, I think, is its ability to transfer knowledge from a, vast corpus of essentially web data and then be able to navigate complex situations and human-made requests. So it can comprehend and execute tasks like, depositing a piece of garbage, even without explicit programming for that specific action, right? So normally when you have a robot, you literally just train it on how to do a task. A lot of times this is very automated. This is not very automatic. And so now, you're telling it, go pick up that piece of trash and throw it in the garbage. And it, based off of everything it's learned and pictures it's seen, will go and try to perform that task, which is absolutely a massive step, right? It's the difference between, perhaps you could train a robot to drive a car from, point A to point B because you just, have it automatically programmed that every inch it's going to turn right or left. It's the difference between that, which is what previously has been done, to something like Tesla's self-driving, where, it's actually looking at the environment around it and making adaptations to how it drives. It could avoid a pedestrian or it could stop at a stop sign. So it's very, this is a massive step. And so, of course, we have something like Tesla self-driving, which follows roads, which have, rules and signs and a lot of information like that, which it's specifically designed to do. This is a whole new step where this is a robot that essentially has to be able to do tasks in the world where there's an infinite amount of actions it can accomplish, and there's an infinite amount of ways to do that. So I think this is really, really impressive. And I think that really kind of demonstrates the model's capability for learning beyond its initial training, which I think is key. So Google engineers put RT-2 through the paces with over 6,000 robotics trials. And in tasks based on the training data, RT-2 performed comparable to its predecessor, which is RT-1. However, when faced with novel, unfamiliar scenarios, RT-2 doubled its success rate from RT-1's 32% to I think it's around a 62% success rate. So I think this improved adaptability is a monumental advancement in the AI model's capabilities. And, I can already hear a lot of doubters or haters or whatever you want to call them, right? Skeptics, perhaps, is a better word, saying, oh, look, this thing's only 62% efficient. It only has a 62% success rate. But look, RT-1 was not put out that long ago. And between then and now, we've already doubled our success rate from 32% to 62% for completely unfamiliar scenarios, meaning you plop this thing down in a park, you say, go pick up that piece of trash, go throw it in that garbage can. It's never been to the park before. It doesn't know necessarily what that garbage can is or what type of trash that is. And it's able to have a 62% success rate executing that task. And imagine, they ran this through 6,000 robotic trials. So imagine how many of those 6,000 tasks it was able to do. I'm absolutely blown away. And for the critics or skeptics out there, I think this is incredibly impressive, and especially the speed of adoption and improvement we're seeing here, I think is incredibly, incredibly impressive. So the RT-2's model is an advancement on its predecessor, obviously, right? The RT-1, which was trained on multitask demonstrations, which was essentially in an office kitchen environment. And that happened over 17 months. So the data collected by 13 robots informed RT-2's development, which allowed it to demonstrate improved generalization capabilities and semantic and visual understanding beyond just the robotic data it was exposed to, right? So it's actually able to see the world around it, actually able to learn, and it's able to improve based off of, right, its experience with everything around it, not just the data that was originally given, which is very, very impressive. The sort of backbone or, the most important part of the RT-2 is the adaptation of high-capacity vision language models, which are called VLMs. But essentially, they have been successfully trained on web-scale data. So these models are brilliant at kind of recognizing visual or language patterns and kind of operating across different languages. But to control a robot, these models need to be trained to output actions. So this challenge is addressed by essentially representing actions as tokens in the model's output, similar to language tokens, right? When we have an LLM like ChatGPT, it's not that it knows, what word necessarily goes next. It just knows what token goes next in a sentence, which is a fraction of a word. And by making it fractions of words, it's actually a lot more accurate. And that's essentially how these LLMs are able to generate sentences. So they've done the same thing, except now they're calling actions or parts of an action tokens, right? So you might need 100 tokens to complete a specific task, and it doesn't have to know exactly how to do the whole task. It just knows how to do micro movements, putting it towards that task, which is absolutely fascinating in my opinion, and well done to the DeepMind team on doing that. So DeepMind actually performed a series of qualitative and quantitative experiments on RT-2 models. And in this process, they categorized skills into 3 areas. So they had symbol understanding, reasoning, and then human recognition. So tasks requiring knowledge transfer from web pre-training essentially demonstrated its, pretty remarkable potential, but with significantly improved generalization performance compared to previous models. I think that that's absolutely important. So on tasks seen in robot data, RT-2 retained performance while improving on unseen scenarios by almost double, which essentially was showing, a really massive benefit of large-scale pre-training, and it outperformed multiple baselines on unseen tasks and achieved a success rate of 90% on the open-source language table suite of robotics tasks in simulation. Furthermore, RT-2 actually proved capable of carrying out more involved commands that required reasoning about intermediate steps. So this actually showed that RT-2 can plan from both image and text commands, and essentially is, enabling visually grounded planning, which is really, really impressive. I think RT-2 showcases how vision language models can evolve into really powerful vision language action models, and that can really directly control a robot. So I think this is promising, and this whole development really signifies the dawn of a new era in robotic control. And I think it really raises hopes for the creation of general-purpose robots capable of reasoning, problem-solving, and performing a diverse range of real-world tasks. So while Google admits there's still work to be done, the success of RT-2 is a testament to the potential advancements in generative AI and LLM technology. And I think the leap from RT-1 to RT-2 really just kind of underscores the immense strides being made in the field. Now, I will say, of course, this is incredibly exciting, incredibly interesting, but I will say that there are some concerns here, right? If you really think about it, as these robots essentially are sitting here and learning how to take in the environment around them and do certain tasks, it brings up the question of robotics ethics and, a whole Terminator-style event essentially happening where the robots are able to learn how to do something, right? Maybe they learn how to drive a car, and maybe they learn how to rob a bank, or maybe they learn how to fly a fighter jet, or maybe they learn how to commandeer a freighter ship, right? Like there's all sorts of things that these can essentially learn how to do. And I know a lot of people think like, oh, this is so far-fetched, but in my opinion, based off of, things I've seen from ChatGPT or Inflection AI, I think there's all sorts of dangers that definitely we need to be aware of. I think the number one most important thing is making sure that the preservation of human life is the top priority for these robots. And then, of course, that begins at the AI model, which is kind of the brains of a lot of this. So it's going to be really interesting to see how this evolves. And I definitely think that is a major area of focus we need to continue to be very vocal about in whatever respective fields we have.
This episode is brought to you by Shopify. Forget the frustration of picking commerce platforms when you switch your business to Shopify, the global commerce platform that supercharges your selling wherever you sell. With Shopify, you'll harness the same intuitive features, trusted apps, and powerful analytics used by the world's leading brands. Sign up today for your $1 per month trial period at shopify.com/tech, all lowercase. That's shopify.com/tech.
Thank you for listening to the AI Chat podcast. If you enjoyed this podcast, I'd appreciate it if you rate us wherever you listen to your podcast. And if you're looking for an innovative group of AI enthusiasts, make sure to check out our Discord channel and Facebook community. It's obviously a lot more interactive than a podcast where we can share software, tools, and prompts we're using in AI every day. I'll leave a link for those in the description below.